evening, everybody. On behalf of Gyanadab and Gyanpedia, our banner under which we do programs on knowledge, it gives me great pleasure to introduce you our guest Ajay Singh. The details of Ajay Singh and the formal introduction will be done by Apurva. Today we are touching a very important subject on water conservation, and none other than a very famous railway man, Mr. Ajay Singh, who will give us a presentation on how he has worked for water conservation and management in Bangalore in the wheel and axle factory. So I now request Apurva to please introduce our guest tonight.
Yeah, today's talk is titled Experiments with Water at Rail Wheel Factory. It can also be called Sustainability in Water for Manufacturing at Rail Wheel Factory. Today's talk is by Ajay Singh, who is a serving railway man, and this is about sustainable and scalable water conservation. And this is not for a housing colony or somebody's home or some society, but it is for a massive manufacturing plant with a voracious appetite for processed water. And during 2016 and 2021, when Ajay Singh was the chief mechanical engineer and the planning engineer for wheel and axle plant, he left an effort in successfully conserving and rejuvenating water sources within the massive wheel and axle plant factory, which is called Rail Wheel Factory now. And every day their requirement is something like 2 to 3 lakh liters of water. And this particular factory is located in Yelahanka, which is generally a water deficient area of Bangalore. So, and a spin-off from this conservation effort is that now that area, the rail wheel factory area, has got creation of a wetland that sustains a wide variety of flora and fauna. And so Ajay Singh, he's a serving mechanical engineer of the Indian Railways, and he has served in various assignments of the railways like maintenance of locomotives and trains, crew management, disaster management, manufacturing, product development, policy formulation, new product introduction, academics, logistics, waste disposals. Bio toilets is one of the very important areas that he has worked in, and his expertise on water conservation has actually put him on several consultative committees of similar large-scale projects in the rest of the country, in railways and other sectors. So without taking more of his time, I pass the stage on to Mr. Ajay Singh of Indian Railways. Please go ahead.
Thank you. I think it's a big privilege for me to be associated with Gyanadab. Thanks to my friend Apurv and Farooq Bhai. I will start sharing my screen. My talk is going to be in form of a presentation, but it's not going to be a very staid and a sarkari kind of presentation. That much I can guarantee you. Yeah. Okay, so I think nowadays all of us agree that water is something about which all of us have to become serious. And as Apurva told, not only in the context of residential scenario, but even in organizational scenarios like railways or factories and all. So today I'm going to share my experience of Rail Wheel Factory, where we were able to successfully take requirement of our processed water from rainwater harvesting at a very, very large scale. So in this presentation, I'll be mainly focusing on what we did. There are many questions which I'll leave to the end of the presentation. So Rail Wheel Factory, basically, it's a unit situated in Bangalore. It's a unit of Ministry of Railways, and we manufacture wheels and axles for railways application. And this photo, by the way, has been taken by Apurva. This explains where Rail Wheel Factory fits in the overall scenario of Indian Railways. Indian Railways is having a very large scale of fleet of rolling stock. We are having almost 1,200 locomotives, more than 2.5 lakh wagons, almost 70,000 coaches. And all of this have something called a bogie. Now, normally a non-railway man calls a coach, a bogie. I mean, the passenger vehicle where one sits as a bogie, but that's a misnomer. A bogie is a structural part which sits below the coach and the wagon as well as the locomotive. So at Real Wheel Factory, we make the wheel set. The component, what you see here, in the gray, the two wheels and the axle, it combined, it's called a wheel set. We manufacture wheels, axles, as well as wheel sets. So on a typical day in Rail Wheel Factory, a wheel is cast every 2 minutes, an axle is forged every 4 minutes, and a wheel set is formed every 6 minutes. So this is a small video clip I'm just adding. So you can see when we are basically casting almost 400 tons of steel and forging almost 200 tons of steel every day, definitely Pollution Control Board will classify us as a red category industry. So we do have a large water footprint, and if you take RWF's water balance, our fresh water is sourced from STP, BWSSB fresh water, recycled water from BWSSB, that is Bangalore Water and Sewerage Supply Board. Sometimes, very rarely, we get water from tankers also. We have our own bore wells, and we do have some open wells. On the consumption side, the main consumption is inside the plant. We have the administrative building, hospital. We have two residential colonies, East Colony and West Colony, and we have a big marriage hall called Utsava. So RWF is spread over a campus of almost 291 acres, out of which 191 acres is in the plant and 100 acres in the two colonies. So if you see on the supply side, we are almost getting 15 lakh liters of water every day, which we are consuming. This is a measure of how it comes from various sources. And on the consumption side, again, this balances off. And basically, the main, if you see inside the factory, we are using almost 5 to 6 lakh liters of water every day. Now, inside the factory, the main consumption of water is for process cooling. Basically, we are a hot shop. We are a big foundry, huge foundry. And for cooling of our furnaces and other equipment, we need almost 2 to 3 lakh liters of water every day. And we have these two huge water tanks. They are overhead water tanks. We call them emergency water tanks because they save water. And in emergency, when power failure is there, from the gravity, it flows into the furnaces. So this is an indicative of our process water requirement. And as I told, it varies from season to season, as well as what kind of production we are going on. When we see a typical wheel, or for that matter, any product, we think that it is only made up of, steel and various alloys and other thing. But now a concept of, embedded material has also come up. If we really see, lots of things are embedded in it. All these things are basically, substance elements and other things, which raw material, which has, besides the normal raw material, what has also gone inside the wheel. So if you take a typical wheel, besides the steel and other things, it will have water. It has a sand footprint, lots of plastic in packaging of incoming raw material and other things. Wood is used in packaging. So it is having lots of embedded substances inside it, besides the obvious raw materials. Now, water amongst this is one of the most important embedded element. And if we do a rough back of the envelope calculation, we make up to almost 1.5 to 2 lakh wheels every year. So in each of the wheel, 200 to 300 liters of water is embedded. If we see how this process water was sourced, this is a typical graph bar chart for water supply in 2017 month-wise. And as you can see, the orange portion is the largest source of water, which is coming from BWSSB. This is not fresh water. This is a treated water, STP output of from BWSSB, what we were taking. Then we were getting some water from our internal plant STP, as well as 2 open wells. This is a satellite image of RWF. If you see, it is situated here, and We do have various lakes around it. Water bodies are already there. Yelahanka Kere, Putanhalli Kere, Alalsandra Kere is there, and Jakur Kere is there. So RWF is surrounded by lakes. On the north side, it is almost a contiguous, one part of our campus is almost at the same level at the Putanhalli Kere, but another part is on a much higher terrain. We do have a excuse me. The area of plant is around 191 acres, which roughly translates to more than 7 lakh square meters of land area inside the plant. If you see the annual average rainfall in Bangalore, it is almost a meter, and multiplied, it gives us almost, the rainfall which comes on the campus of plant is almost more than 7 lakh kiloliters. So once we started this project, this was some kind of rough calculation we did, and our plant daily requirement taking around 3 lakh liters per day and 300 working days maximum in a year, it was coming to 90,000 KL. So you can see very well that as against annual rainfall, which is coming on to the complete campus of 7 lakh plus kiloliters, our requirement was only 90,000 kiloliters. So this gave us some kind of, assurance that if you are able to harness a good part of rainfall, which is incident on campus of RWF, we will be able to meet our process water requirement. So we started with this premise. We also found out that, a maximum lean period based on 100 years meteorological data is 100 days. That is in our part of Bangalore. Within 100 days, definitely some kind of rains will be there. So if you take a straight back of the envelope calculation for engineers, the storage capacity required is 300 kiloliters per day into 100 days is almost 30,000 KL. But after this calculation, I abandoned all engineering and I went, this project, what we had used is basically the rainwater harvesting techniques, which are prevalent in traditional rainwater harvesting. And we, in complete this project where we became water self-sufficient for process water, we did not created any, big concrete storage structures and others. We'll see as we go ahead with the presentation. So this is a close-up of the RWF plant area, and we had a low-lying area. So what we did was we tried to develop our project around this low-lying area. And when we looked around, we found that there were 2 wells there. One was named as Kandaswamy well, another was called Damodar well. Then on further inquiry, we found out there are 2 abandoned well also. The third well was called Itko well. And somebody told me that there is a 4th well. It took almost 1 month of, hard looking around and, clearing off a bit of jungle. Then we discovered that, yes, 4th well was there. So when we started our project, we had 2 active wells and we had 2 totally defunct and abandoned wells. When we studied the low-lying area and what were the stormwater drains, we found out that there are 2 distinct stormwater drains which are collecting water from the plant area, and they are coming. And if you see here, this part, actually, this white lines, what you see, these are railway tracks. So one stormwater drain was emptying on the north of the track and another was towards the south of the track. Then we had these 4 wells and we had some culverts which were taking out all the excess rainwater to the lake area, which we saw just now. So the catchment area, we can distinctly tell that one catchment area was of the axle plant, another was of the wheel plant, and there was a third catchment area which was basically covering our front entry area and our marriage hall area, which is called Utsav. So these 3 catchment areas we identified for the complete plant. And luckily for us, this low-lying area was having inherent boundaries. On the north of it was the actual wall boundary, which separated this low-lying area from the Putanhalli Lake and marshy land, which was beyond it. And on the south side of it, you had this straight white line, which is the track, which is on an embankment. And this red area is actually, we are having an area where we dump all our foundry waste, which we cannot co-process and use it. So over a period of 35 years since this plant was in existence, we have kept all this material. So these three formed a natural boundary for our low-lying area. And we started working on this low-lying area. That was the plan. So this is a still close-up of the area here. In fact, in the satellite image itself, you can see this small, this is a well, Kandaswamy well. We have one well inside here called Damodar well, and one well here, another fourth well somewhere here. These are the stormwater drain. This is the picture which we took in 2017, just before we started after we started the project. So this was the axle shop stormwater drain, and this was a stormwater drain of wheel shop. You can see it is all kind of almost buried below, beneath lots of debris and other things. So initially, when we started this project, we thought we will make our own lake inside the factory. So we named it as VAP Kere. VAP is basically wheel and axle plant, which is the original name of rail wheel factory. The plant started as wheel and axle plant in 1984, and somewhere down the line in 2004, it was rechristened as rail wheel factory. So still lots of people have very fond memories of the name VAP. So we kept the name of this water body, what we were planning to create, as VAP Kere. Kere is, Kere is basically a lake in or a pond in Kannada. So this is the name of the lake what we thought we'll make. We thought that we will make lake it in various parts. So what we are going to have is we'll have one part, second part, 3, 4, 5, 6. We'll make these small lakes, and ultimately we are going to join. So we started with this premise and we started working on the project. So the first phase 0, you can say, even before we started on 24th of April on 2017. And we did a recce of the place, and we had a Herculean task. The green portion, what you see here, is actually a water body. It's not a nice lawn. It's a wetland, and this is some kind of grass which grows in that area. And all around this, you can see lots of debris is lying there. It's a plant debris. Other places also, there's another water body across that. On the far end, you can see there is lots of debris lying. Still another picture of that area. And not only debris, it has become a dumping ground, and many people were putting lots of waste there, and they started burning also. In the foreground, you can see burnt ashes in that area. And even 1 year before I had gone, we started this project in 2017, but I had visited it in April 2016, and this was the condition. You can see in the background, foundry waste is lying, and this is the well, our biggest well, the Kandaswamy well. It's almost kind of dry. And around this area, lots of dumping was taking place. Besides the foundry waste, lots of mixed waste, even the canteen waste and all was going. This was kind of scenario what we had when we started this project. In some other part of that low-lying area, we had lots of packaging which was being dumped there. People had started burning also waste, which they could not think of finding any other way of disposing. So this is one of my colleague in white shirt, Mr. Siva Subramaniam, who played a key role in the project. And in the back of him is Mr. Vishwanath. He's my water guru, and he's a very prominent water figure in Bangalore. So he came, and when he saw the wells, he was very excited. He told, between these wells, if you kind of take care of these, you will be able to get your process water requirement of 2 to 3 lakh liters. So that gave me some kind of confidence. In front, the red board, what you see is the original data for the well. The well is almost 10 meter across diameter and 12 meter deep. It's a huge well. It is the biggest well in RWF campus, but still its yield was only 25 KL per day, 25,000 liters per day. So we started properly after Mr. Vishnath's visit. What we did was, we formally started the phase 1 of the project on 2nd of May 2017. We thought that we'll clean up the whole area, we'll channelize different water streams, and we'll consolidate whatever water bodies we create. So with this motto, we started off. And first and foremost, what we did, we took out some old railway sleepers, we put them there as markers, and we created an eco zone. And we told everybody that this is now eco zone, and nobody must dump anything, no one should dump anything in that area. So we first started fresh ingress of waste material in that area. Then we started clearing it up. So we engaged, luckily for us, inside our, we had our own resources of, different vehicles and all, heavy vehicles, earth movers also. So we put them in, we press them into service. There's a tractor trolley carrying wooden packing material. We had a poclane machine also and dumpers also. So we started clearing off the whole area. And internally, we had set a target that, okay, it is now May, full May will work. And in the June, when World Environment Day is there, that time we will declare the project formally open. So with that area, we started off our phase 1 in right earnest. On 27th of May, Mr. Vishwanath, who's got a Twitter handle of Zen Rainman, he published an article in the Hindu on our project. Our project, mind you, our project has just kicked off, and he told that a walkabout can save the city, and he gave an example of our project. That was a big booster for our team. We thought, okay, we have started and we are just kind of beginning, but we are on something really good and really positive. So after a little bit of cleaning, this is the site where we thought that we'll start the first phase of our project. In the rear, you can see the Yelahanka lake. It's a huge lake of almost 500 acres. You can clearly see our boundary ahead of that. And the green patch in the middle, what you see is the water body, what we had. Around that, still you see, lots of debris lying. So after 1 month of hard work, this whole area became like this. You can see all the surface debris has been removed, all the muck has been removed, and it has been cleared. This is just one day before the inauguration on World Environment Day on the 5th of June 2017. What we had decided was we had this center water body here, and we had a small water body here. Actually, when we started to think that we are going to, join these two water bodies, by this time we had already cleared almost 169 dumper lorry loads and 2 tractor loads of muck from here. So this is what we thought, we'll join these two water bodies. And actually, when I had planned for joining as a part of inauguration, I never knew, how much water, what kind of water is there. On the World Environment Day on 5th of June 2017, even before kind of project went on full steam, I declared in the function that we are going to have this project. We are going to create our own water bodies. We'll revive our water bodies and become self-sufficient in our process water requirement. We took the head of our family, the general manager, Mr. O.P. Agrawal, and we asked him to do groundbreaking for the function. So he did that, and we took all the senior officers and we asked him to do some kind of tree plantation. And by the time tree plantation was being done, we had placed our poclane in such a manner that in one go, he was able to connect the two water bodies. And like a very good omen and like a very good portent of signs of things to come, we saw water gushing in from one water body to another water body. It was a very, very kind of positive sign, and we were very happy about that. One of my colleagues, the security commandant, who's otherwise very stiff and very rigid RPF officer, he has brought some ducks for the occasion, and he left those ducks in the water body what we had cleared. So after this, the function and everything was over. Then the phase 2, the real act started. From 6th onwards, the real work started. And to my disappointment, what we saw was on the 6th that we had joined the two water bodies, and what has happened was whatever water came from the upper water body to the lower water body, it just went out from the culvert. So that was, kind of a big setback, and we started thinking what to do. And this is the place from where it was going out, and it was simply going from so-called not yet to be born Vapkere to Putenhalli Kere. So I, thought about making a simple bandh here. We created a wall here so that this our water will be kind of held inside our campus, and only excess water will overflow to the culvert. So there's a small intervention which we did, and after that, you can see this bandh in action here. After one of the rains, the whole area is full of water. It's very clean water, and only the excess water is overflowing over this bandh out of the culvert. So this is the main thing on Vapkere. First Vapkere we started working on that. First, we started working on the stormwater drain. We started diverting it. We made some concrete path for the water to flow down because it was at an elevation of almost 5 meters. Then we created a kacha water path for this stormwater to go down to the water bodies what we had created. Now, this was very deliberate. We did not create any concrete channels. We created an open channel like this, and afterwards, in fact, when you go, you will not be able to see it because it is full of vegetation. It was very deliberate. It was kept kacha so that lots of water will get absorbed here also, and the vegetation, the wild vegetation which has grown inside it, it slows down the velocity and the force of the water. Otherwise, there was a chance that the force, the water is coming with so much of force because of the gradients that it will, overshoot, and it might even damage our boundary wall. So we created a water path like this towards our water bodies. And on the other side, we started enlarging this water body. And this is the exact location where we did the inauguration of the project. You can see we have deployed the poke-lane and the dumper, and we are kind of digging out the area. And while creating this water body, we had not used any cement. We have not even used, anything to stone pitching or anything for securing the embankment. We just left a slope and let the plants and everything to take care. So these are some of the pictures over a period of time. During initial phase when we were enlarging this reservoir, you can see already so much of water has collected there. On one of the days, rather it was a night, 8 o'clock, when I was going around this, on the right side, the stormwater drain is there on the height from the axle shop. It comes and almost takes a very, very rough 90-degree turn. It's very violent here because water, it's very difficult to tell water to take a right turn or left turn. So we thought that if we leave it as it is, the force of the water will, cut the road which is there, peripheral road which is there on the left, and it will damage the boundary also, which you can see in the left. So we did some kind of stone pitching here and made a gentle curve so that sloping curve so that the water can get diverted 90-degree here. So after a month or so, we had enlarged the area around well. You can see a freshwater body has been created on this side. On the other, the digging what we saw was on the other side, and this is the reservoir what was created. You can see the slopes are still raw, kind of they have not yet stabilized. So by 7th of July 2017, we had already moved almost 266 dumpers load of muck as well as earth what we took out for creating these water bodies, and 2 tractor trolley loads of various packing material and other things. So here you can see the well, it is full, and this well itself, when it is full, it holds almost 10 lakh liters of water. So this is how the water body progressed over a period of time. We allowed it to, get overgrown with whatever weeds are there. These are actually water plants only. It's a cat's tail. And in the foreground, what you see is the original grass which was there. And this area, it developed on its own and kind of matured and became secure. So this is after one of the rains, you can see the clarity of water in the well. Water well is full. And this is a close-up. This water quality is so good after it comes near the well that I think more than 80% of India's population can, use this water straight away without doing any kind of intervention like RO or, filtration and any other things. So this is the, after we finished rejuvenation of our first well, this is the photo, and this is from where we had started. So this is our biggest well, and after we had rejuvenated it, the yield from this well itself increased from 25 KL to almost 125 KL. It went 5 times, more than a lakh liters of water we started getting daily from this well itself. Then after this, we moved on to the second phase of the project, which we call VAP 2. So this was actually one of the water bodies. You can't see any water body here because it has been, filled up with all foundry waste and debris. So here we started digging, and after about a month of hard work, we could create this water body. This is the same area, exactly same area after one of the rains. You can see that it has started holding water. In the foreground, still you can see some kind of debris, and in the background also a little bit of debris is visible, but the large portion of it has been cleared. At this stage, we again encountered another culvert we discovered where water was going on. So here also we did an intervention. We didn't made a proper masonry kind of bund, but we just made a mud bund around this so that that area will also hold water. So then this is how we charge the Damodar well. This well already was our best yielding well, but before we rejuvenated this area, it was giving around 75 KL daily output, which again went double to almost 1.5 lakh liters of output every day. Then we started working on a remaining portion of the lake system, what we had thought will create. And we went actually to seventh segment of this, and we created a very linear kind of water body there. So these are some of the photos during making of that water body. And after this was made, after first rains, you can see it is having water, but it's very muddy because the soil dug is very fresh. And this was the well which was recovered in the centerish. You can see this well here. This was the well which was totally buried. This is called Somashekara well, and this is after the water, all the dirt and all has settled. You can see the clarity of water, rainwater, what we were getting at this location. This well also was this was a much smaller well, so the yield was around 10 to 20 KL per day. So this is from where we had started. This was the condition of the well before we started, and this is the condition of the well after it was rejuvenated. Then we actually came to the other side of the track. All these 3 wells were on the north side of the track. Then we came to the south side of the track to take care of the 4th well, which was the Itko well. Itko well was getting water from catchment area of Wheel Shop as well as from outside, from Utsava side. So we had a very peculiar thing there inside. Water used to get flooded in part of that marriage hall. So we made an opening there in the boundary so that the water will flow out and get into this area. So this was the condition of the well when we started the project. The Itko well, you can see it is totally abandoned. It's in disuse. For this well, we had to create a totally new water body. It was a huge reservoir what we started making. It was called Vapkere 8. And you can see this huge reservoir. Actually, the size of it is not very obvious, but when it was being constructed on the far end, what you see the vertical surface, it is equal to 1.5 dumper height. A dumper is a very high lorry as it is. So that side, it must be almost 3 to 4 meters high, the far end, what you see. And in the background, what you see is the embankment on which a railway track is there. So this was just abutting railway track. And after first rains, you can see this is full of water. And of course, because it's first rain, it's all muddy. This from one end and this from the other end, where at the far right, you can see the well also. Here is the Itko well. So we created a big water body all around, which went into the area where the stormwater drain from the Wheel Shop was coming. So this was the fourth well which we rejuvenated. This also started yielding almost 15 to 20 KL of water every day. This new reservoir, since it was totally dug new, it took almost 2 to 3 years to stabilize, and nowadays it has started holding water. Otherwise, after rains within a week or so, all this water used to disappear. So this is the well number 3, fourth well in our talk, what we rejuvenated. And this is the reservoir what we created. So it was getting feed from the wheel shop catchment area, as well as this is the area what I told about the Utsav. This is the place, the red dot, where we created an opening in the uh, marriage hall area boundary, so that the water can flow like this. This is the small opening. It's a 1 feet by 2 feet opening what we made. This also solved the problem of flooding inside the one part of the marriage hall. So this is a photo of the well after we had rejuvenated it. Of course, because the wall was very low, even the surface runoff entered, and that's why this water is very, very muddy. After that, we took up cleaning of these 4 wells also. So this is how we started our journey. This was the condition of ITCO well when we started, and this is post rejuvenation. So this is in a very fast manner, the 4 water wells what we rejuvenated, how we rejuvenated. Of course, the whole exercise was spread over almost a year, and in between we had a big setback. This is our, again we are visiting the low-lying area. You can see the big well, the Kandaswamy well. Adjacent to this, our water body is there. But one fine day, somebody told me that one big area of 50 meter by 100 meter in that place is being handed over to Southwestern Railway for putting up a traction substation. So we, this would have destroyed our complete project, because this is the first landing for our stormwater drain where the water was coming and getting collected. So we kind of opened a dialogue with Southwestern Railway from RWF, and we persuaded them to shift this traction substation to a slightly adjacent location. And in the process, what we did, we saved our main water body. And one very interesting thing, this is the constructed traction substation. The traction substation is behind this boundary. So we took advantage of this problem and we turned it into a solution. What was happening, I was, taking out lots of earth for creating these water bodies. In fact, when the project was matured, after that, by that time, we had moved more than 1,000 lorries of, either the muck or the mud or earth for creation of these water body or clearing this area. So this traction substation is an electrical substation, so it has to be at a height. And since this was water saturated area, they had, you can see there is a ground level which is higher than the ground level outside. So we use this area, all earth what we're taking out from the water bodies, we dumped here, and we use their area 50 meter by 100 meter to kind of deposit our earth what we were taking out from water bodies. Secondly, what we gave them the land but not the water. So whatever rainwater was falling, we asked them to design in such a manner that we had weep holes all over the boundary, and we had a collection gully created all around this, which used to go and feed into the reservoir for the Kandaswamy well. So this problem we kind of turned into a solution for ourselves. So this is actually now constructed traction substation. You can see this water body is not affected. Here also there's a water body which is not affected, and in a corner we gave them the land. So this was one of the problems which came up during making this whole low-lying area, turning it into a wetlands water body. But there was another problem in parallel going on. This problem had been going on for quite some time. Since we are a big foundry and we are inside almost city nowadays, we had to take lots of efforts for dust mitigation in exhaust of furnaces. So we had this huge structure called primary fume extraction system, through which all the the hot air from the furnace exhaust used to go and get cleaned off all the dust particles, and the emissions which is coming out of chimney will be not having any suspended particles. But part of this fume extraction system was underground in a tunnel, and this strata was having a problem of water saturation. So you can see this strange tree trunk kind of thing is actually a filter bag, which is a cloth filter of 6 meter length. It is totally soaked with mud and all, which is coming from the furnace and getting saturated because of the ingress of water in the tunnel. Here you can see one of the employees, he is trying to clean this bag. So this was a big problem. This not only this immediately affected the efficacy of our fume extraction, and it was creating problem because our emissions were increasing. So what we did was, to solve this problem also, we sank 2 wells, and these were kind of mitigation wells for these were put adjacent to the tunnel, fume extraction tunnel, to take care of the water seepage. And all the water, we put a auto pumping arrangement in this, and this well also started yielding water without our intervention. In our basement area of furnaces also, we put another well, and you can see average daily yield of these two wells combined was almost 16 kl. And cumulative, this old data, and we had more than 1 crore liters of water from this problem what we had. So this was these two wells were created to solve a problem of water seepage in the tunnel, and it kept on giving water output, which we again put it back into our cooling water system. Then we went to create another thing. We saw that during rains, our down pipe, since they were putting what this is a 6-inch down pipe, the diameter down pipe, and you can see the extent of water which comes out from this down pipe. So what we started doing was, we made something called rainwater mega harvester. This I designed based on my experience of designing bio toilets for Indian Railways. And in this, we had, we diverted 6 of the down pipes from the rooftop, and the rainwater will come, it will get filtered, it will get sedimented, and with overflow in this big 60 centimeter pipe, it will go to the cooling water circulation system adjacent to this installation. So this is the first trial what we did after one of the rains. You can see this water is getting collected here, and it is getting shifted to adjacent cooling water system. You can see the yield here. So the best part of this installation was that we were capturing not only rainwater. In the earlier instance, when we were developing the wells, we used to collect rainwater at a mega scale, let it go and get seeped, and we extract from the water. So lots of pumping was involved. In this installation, we were not only capturing the water, we were capturing the potential energy also. These rainwater mega harvesters were automatically every day were yielding almost 25 kl on a rainy day. So this, we put 4 mega harvesters like this, which between themselves, they were giving about 1 lakh liters of water. Then one issue with this kind of installation of rainwater mega harvester was there, that we can install it only near to where cooling water circuit was there. We had other roofs also which we identified, you can see in red marking there, but it was very difficult to take them to the cooling water system, circulation system. The piping itself would have been very tedious and a bit expensive. Then we came upon another idea. We created in one of the areas near our pump house, which was low-lying area, we created a sedimentation cum filtration bed, where once again no pumping was involved. The rainwater used to just flow. Here on the left, you can see the rainwater is getting captured, it is getting diverted into this structure, and we were using the the head available, the gradients available there, to pump the water directly, push the water directly to the ground level reservoirs. 270 kl reservoirs are there in the background. This is, you can see this water front collection channel is there. It overflows. There are 4 sections. The water flows under, then over, and then under, and then finally on its own it flows and goes into the 70 kl to ground level reservoirs. So this is after construction, and here you can see the pipes which we laid for putting the water into 70 kl ground level reservoir. The structure is in the rear here, and here you can see during trials. This is after rain. You can see water is just coming out. There's no pumping involved here. Water is getting sedimented and filtered, and in both these are the two outlets. Just before we connected it to the outlet, this is we were testing. So you can see water is, such a good flow is there. And this contraption itself was yielding more than 1.5 lakh liters of water every rain. So because of all this, what happened? We became water surplus. In fact, what happened during rains, we were having water which was kind of overflowing all our cooling water system ground level reservoirs. We have 18 lakh liters ground level reservoir at the pump house. They were overflowing. This is a graph of how we used to source BWSSB raw water for plant cooling water requirement. You can see after September 17, we started the project in June, and by September 17, we had kind of stopped taking raw water from BWSSB. But again, in the year 19, January 2019, we had, kind of very dry season, because of which our well yield was not enough, and we had to take water from BWSSB. So this prompted us to have a rethink. When we did a survey of that area, we found that, that water is available in that area, but the seepage into the well is problem. So what we did was we sank 2 more wells there. 2 additional wells were sunk in the ecozone low-lying area. And we did a very innovative thing there. Instead of, this was the area where we identified, and, this is where 5th well was sunk, and this is the location for 6th well. And this is the 5th well after it has been erected. What we did was, basically, you can see here, instead of pumping it, these wells actually, they were pumping water to almost 1 kilometer away ground level reservoirs, what I showed in another slide. So these 2 wells, what we did, small wells, we piggybacked them to the bigger wells, 2 adjacent bigger wells which were there. So what we did a pumping arrangement from which used to pump water from this small well to the bigger well, and from bigger well already we had, the big pumps which were carrying it to the main ground level reservoir. So we saved the lead, the pumping, piping and all. And the trigger for these smaller new wells, 5th and 6th wells, were from the big well itself. Once you start pumping in big well, automatically small wells start pumping into the big well. Of course, we became water self-sufficient for doing that. Apart from this ground level work, we had to augment our pumping. This is the well water pumping diagram. We had to put some additional lines. We had to upgrade our pumps from 5 HP to 10 HP. Then the Somshekhara well and Itko well pumping was defunct. We had to reintroduce. Then 5 HP pumps were put in the new 2 wells. So when all this was happening, what happened somewhere in 2019? Suddenly, the media took up this thing that Bangalore is going to, have a water crisis, and Chennai, Bangalore and all, we are going to run out of water. In fact, there was one famous BBC news article where they told that after Cape Town, Bangalore is the next city which will run out of the water. So somehow, because of this or otherwise, our project caught attention of Bangalore city, and we got lots of media coverage over a period of 1 year, 2 years. In fact, this is a paper for February 2018, when Bangalore Mirror gave us a front page, top of the fold coverage, where they told that Rail Wheel Factory does what Bangalore should do: clear trash, collect rain. And they did a almost 1-page coverage of our project. Then it was followed by many other papers. This is Deccan Herald. They gave us main page, top of the headline, as well as inside coverage. This is again a second coverage by Deccan Herald. Then, of course, it all has started with a write-up by Mr. Vishwanath in Hindu Property Plus. And there actually he has written about, the wheel and axle plant. He used the old name, not the railway factory. So there he talked about our project, and that we are going to develop it into ecozone and wetlands. So this was much before we kind of did. We also got coverage over the net. I will not play this.
The rail wheel
because of paucity of time. And the most surprising part was that we got, some fan mail also. And I was very happy to get a inland letter after, maybe probably 20 years or so, when one Bangalore citizen wrote that he's very happy about our project. In this process, the whole area turned into a very good eco zone. And we had lots of different type of flora, fauna, different reptiles, a large number of insects, including more than a dozen type of butterflies and more than half a dozen type of different dragonflies. These are some of the pictures which I kept on capturing during my walks to the area. These are some of the birds, including some migratory birds you can see here, which used to frequent us in the ecozone. And we are very proud to have a good flock of peacocks. Now it's more than 2 dozen which they are there in that area. And of course, we thought that since water is there, let us stock some fishes. So we got fisheries department. They helped us in identify what all fishes to stock, and we got more than 3,000 baby fishes, and we put in the various water bodies. This is one of my Nat Geo moment where I captured 2 snakes and 1 fat toad. This picture I took it inside the big well, the Kandaswamy well. And, they were all kind of somehow they managed to get inside the, of course, toad lives there, but the 2 snakes got inside the well and they were not able to come out. And the funny part, it's almost, so comical that a fat toad is there, but they are not eating it, because if they eat, they will become so heavy that they will sink and die. So this is one of those rare moments where, just everybody is trying to save their life and coexist. To make these efforts sustainable, what we did was, after this eco zone was created, we started going to this place during all our monthly retirement functions. We used to take our retiring employees there, and we started, getting tree plantations done by those people. Then, we had different shramdans organized there for cleaning up the area. And during one of the shutdowns of the plant, we took almost more than 300-400 people there. They handpicked all the rubble and other waste lying there. In fact, during this 1 week campaign, they handpicked 25 metric tons of scrap iron and other things which were lying there. And of course, we spread this movement to our school also. We have a Kendriya Vidyalaya, and I'm proud to say that this Kendriya Vidyalaya got top position in NDTV schools campaign. It was covered by none other than Amitabh Bachchan. I will not show that clip here. Of course, when we talk about a project like this, this was a very informal kind of project, and it can kind of drew its strength from the traditional rainwater harvesting methods and other innovative engineering. So there was no formal project as such, there was no project, there was no cost estimation and other things. We kept on, making small interventions. And if you really add up, it might come to cost, cost of about 1 crore spread over 4-5 years. And we kept on doing small interventions. Like this is a photo, one of the nights when I came, I saw, that at one place, water is taking a very hard 90-degree turn. Whereas on the left, just below this light spot, there is a, water reservoir what we created. So next day we got hold of, few of us, and we just took whatever we could lay our hands on. And on the left, you can see this water is coming from this area. We started making a water path so that, this big reservoir what we created on the right side, water can easily straight away flow into this. So these are the kind of interventions we kept on making. We kept on studying how water is behaving in the area, and we kept on kind of cajoling water to go into these reservoirs and create a wetland there. So of course, if it is a PowerPoint presentation, you got to have some graphs and all that. So this is actually, you can see yearly what is the average daily treated water what we used to get from BWSSB. So you can say it is in the region of 2 lakhs to almost 3 lakh liters up to 16-17, 17-18. It dropped down, and 18-19 it was very less. 19-20, because of the dry season, it got up, and 20-21 it was bare minimum. This also actually includes some little water what we are getting for gardening in our colonies. So actually plant water has become zero from BWSSB. Not only this created, reduced our process water requirement from BWSSB, it affected our overall water, what we used to take from BWSSB. This is total potable, non-potable, everything combined. We used to be at 13.4 lakh liters average during 16-17. It fell down to 10 lakh within a year. And, it is kept around 10 lakh liters since then. So it has made a positive impact on overall BWSSB water drawal also. So we feel proud that not only we have become water self-sufficient, effectively almost 3 lakh of liter we are giving back to kind of Bangalore city, because BWSSB can divert this water from not from our uses to other uses. Of course, all this has resulted in savings also. If you see our water bill, our annual water bill used to be in the region of 4 to 4.5 crores. Now, after 17-18, you can see our annual savings are almost 60 lakh. In 2021, saving is much less because of, there was increase in tariff, as well as there was water consumption has gone up because of higher level of production. But you can see, even if you see cost wise, within 2 years of the project, we have recovered the cost, whatever we have spread over, 3-4 years of 1 crore. So then we came to the next stage of the project where we started, diverting water. So this was the nice garden of our admin. You'll be surprised, but we were using Kaveri water for this gardening. So after we became water surplus, we started diverting our plant STP water for this purpose. Then we started using water which we were generating from the wells for flushing also. Then we had a big fleet of vehicles. So for that washing, cleaning and other things, we started using the well waters. We had fire engines inside the plant. All this water was well water. Then we started working on, different toilets in various workshops and start making their flushing arrangements with this well water. So after this wells were created, in fact, we ended up with 6 wells in ecozone. In wheel shop, 3 wells were there. And we had totally 9 wells, 8 active wells will daily yield. And with this, which we became the, campus with maximum number of open wells in a single campus. So we are an organization with maximum number of open wells in Bangalore. Cubbon Park, which is a much larger area, it has got only 7 open wells. We are already having 8 active open wells in our campus. We did got lots of recognition. We got at local level, state level, and national level also. This was my team. This is, of course, we had support of our senior management also, as well as lots of people, all the way people who used to operate these heavy equipments like dumpers, spoke lane, and other, and lots of people who used to go around to see, do the tree plantation and others. So it was a very big joint effort. And I must thank, this is my core team. Besides being the environment officer, I was heading the wheel plant there. And this is my wheel plant team. And these wonderful set of officers, they did their work so nicely that we not only broke all kind of records as well as production and quality was concerned for wheel manufacturing. I was able to, spend considerable time and work on sustainability of manufacturing inside the rail wheel factory, a big part of which was water self-sufficiency. So then we moved our focus to water initiatives in our colonies. I started working on, making our colonies what is called zero runoff campus. We are having bore wells there. We have started putting a STP there, and we are working towards zero runoff campus. But in between, I have moved on to Southwestern Railway. Before I move on to the next concluding part of my talk, I will request Farooq Bhai. He wanted me to have a break here. I think he got a message for everybody. I'll request Farooq Bhai to please come on board.
Yeah. So I hope all of you are enjoying the presentation, and I just want to give 2 minutes to Ajay Singh to settle down. What I wanted to inform you that Gyan Adab brings this knowledge-based video programs And we request during the program to donate money to Nityasha Foundation, which is our other NGO, where we take care of children with type 1 diabetes. So a typical child who does not produce any insulin, his pancreas lose the power of creating an insulin, and especially coming from the poor section of the society, each child requires around 35,000 rupees per year. So we are now handling about 140 children, and we get donations from people who attend Gyanadab. So I will just run a small video of 1 minute, and then we'll start with the program. We'll continue with the program. One minute. Is the Nityasha window open?
Yeah, we can see that.
Yeah. So this is a small video which I showed you. If anybody wants to contribute, we'll be putting the donate link into the chat box. I know it is difficult to use that link, but if you just leave your phone number or name, our team will coordinate with you, and we will arrange the donations to come into the Nityasha Foundation's bank account. I request all of you to donate generously, because we work very hard to conduct these programs so that we are able to, justify our request for collecting donation. So thank you very much. And I request now, Ajay Singh, please share your screen and begin the.
Okay, back to the water projects. So in RWF, we started, on the next stage, we started focusing on our colonies. But one question comes, why all this? I personally started. Actually, when I moved into Bangalore in 2015 May, I saw, lots of destruction of water bodies. I had left Bangalore in 2004, and after almost 11 years, I was coming back. This is one of the famous places called Kogilu Cross in Yelahanka. There you can see in the background what are the heaps of soil. Is basically, it was a water body there, and I don't know who were the people. They just covered it up, and it just turned it from a water body into some kind of land. And I really did not know whom to complain and what to do about it. So I thought, okay, I can't prevent this, so let's make my own lakes. So this was one of the wild ideas that came. And of course, my interest in water goes back to all the way to 2007, when I started working on this national project of bio toilets while being in the ministry as director development. So we developed something called bio toilets, and now if you have traveled in last few years, you will notice that human waste is no longer falling on tracks. This was a joint project between Indian Railways and Ministry of Defense. In the process, I became some kind of shit expert. But more than that, actually, I realized that, in Indian context, the toilets are having a deeper, fundamental issue of water, especially in rural context, because I was interacting with the Ministry of Rural Development also, and they were struggling to install toilets, bio toilets in villages and all. So anyway, that's how my water interest really started. And of course, I had the fortune of interacting with some of the people who are doing real good work in field of water. They are doing very quietly, whether it is Supan Joshi, who's associated with Gandhi Shanti Pratishthan, or Mr. Anupam Mishra, late Shri Anupam Mishra, who's not there anymore. He did very seminal work in villages of Rajasthan. He has written a very great book called Aaj Bhi Khare Hain Talab. Then, of course, my water guru, friend, philosopher, and guide, Vishwanath sir, who has been kind of guiding me whenever I have doubt. He's my 4 a.m. friend when I can send him a message, when I get stuck with anything related to water. So I consider that, yeah, of course, Mr. Shivakumar is there. He's in Indian Institute of Science. He's, read a newspaper article that, for 22 years, he has not taken any BWSSB water in his house. Actually, this was the exact trigger which kind of told me, okay, if we can live without BWSSB water, why can't I do it in factory? So first, when I started, the problem was too big, 15 lakh liters. Definitely, I can't get it done with rainwater. So then I focused on something which I can solve. That is, I focused on processed water, and I did manage to become self-sufficient. So these are some of the stalwarts of water who are doing yeoman's work. And let me mention, I see Shri Padre Saab in the participants. He is also one of my water gurus, and he has been guiding me because he's got such a huge network amongst water resource people. And of course, since I became so much interested in water, I did, started reading. There are very interesting books, like this Tristan Guli called How to Read Water. Of course, Ajbi Khare's Talab is another kind of Bible for water, people who want to do water related work. Coming to my current assignment in Southwestern Railway. Southwestern Railway now immediately enlarged my canvas. As the destiny would have it, I got an assignment as a Chief Environment Officer for Southwestern Railway. In fact, I'm the first Chief Environment Officer for the Southwestern Railway. Earlier, this portfolio was being looked after by another gentleman as additional charge. So Railway has also woken up to environmental issues, and we created an environmental directorate in the ministry in the year 2015, and later on in the operational units, which are the zonal railways like Southwestern, Northern and all, the environment wing was created. So I'm heading the environment wing for the Southwestern Railway currently, and our geographical spread is in Karnataka, Goa, Telangana, Andhra Pradesh, Tamil Nadu. So I get a very exciting, chance to replicate whatever our learnings were there all across the geographical spread of Karnataka. Of course, we are, having a route kilometer of over 3,000 kilometers, 381 stations, 132 goods sheds, 2 big workshops, 2 diesel locomotive maintenance units, 7 coaching train maintenance units. So there is tremendous, almost infinite opportunities of doing things, many things related to environment. And I'll keep my focus on water. First thing what we have done is we have created a water asset inventory for Railway Factory. I'm sorry, Southwestern Railway. And you can see we are having more than 1,000 water assets. And it's so interesting. We have got a lake, a railway lake, which is almost 380 acres. It's a big, huge lake and wonderfully clean water in Hubli. And we are sourcing water from here for Hubli railway establishment. So I will invite you nowadays. I keep shuttling between Hubli and Bangalore and Mysore, which are my prime work areas. So I'll invite everybody to make a trip to Hubli, and we'll go and have a splash in this absolutely wonderful lake. I think this lake is better than any other lake I have seen. All the tals, Nainital, Single Tal, and all that. I'll challenge Pune also, Khadagwasla also. My first project in Southwestern started in a MEMU car shed. Here you can see we have a problem in the left where water stagnation after rains is there. We have created a small water body, and we are trying to divert this rainwater which is stagnating on the track to this. So we are working on this. Plus, we have taken up a very big water project to convert our colony. It is called Golf Link Colony into a zero runoff campus. We have a 9-hole golf course there inside our colony. So this I'm going to use as a water resource area, and adjacent to this our colony is there. All the water goes there, and we have some 4 borewells there. So my idea is to recharge those bore wells, as well as, at least for golf course purpose, start using rainwater. So I have divided it into 4 different phases of the project. I'll not discuss this project now because of paucity of time. I come to conclusion of my project with this couplet. Ghalib साहब की couplet है, हजारों ख्वाहिशें ऐसी कि हर ख्वाहिश पे दम निकले, बहुत निकले मेरे अरमां, लेकिन फिर भी कम निकले. तो हमारी ख्वाहिशें तो बहुत होती हैं, लेकिन ख्वाहिशों के साथ अगर हम उसको लग जाएं, उनको साकार करने के लिए, so definitely we can make a dent. So with this, I will finish the project. Wherever I'm doing this presentation in Bangalore, I end up by saying that you have seen a presentation on your computer screen, but if you really want to have oxygen in that wonderful ecozone, do visit us. Even though I'm in Hubli nowadays, if you are planning to visit either to Hubli or to Bangalore, do let me. It will be a pleasure and an honor to host any one of you. Thank you very much. Over to you, Farooq bhai.
Okay, thank you very much, Ajay ji. आपने बहुत अच्छा presentation किया. I've been getting very good remarks on the this. I now request Mr. Apurva Bahadur to start the question answer session for Ajay Singh to contribute and answer the questions. So please, Apurva, over to you.
Yeah, Ajay, one question is that suppose Ajay Singh never went to wheel and axle plant. So, and the people inside that didn't have any vision for water conservation. So how was it designed with such massive requirements of water? If you didn't take the initiative and you said, हाँ भैया कचरा पड़ा है तो रहने दो, water body नहीं recharge करना. And how was WAP designed on the drawing board where they said that we need so much of water? Where was it going to come from?
Actually, as I told earlier, we used to source this water from BWSSB, as well as the 2 wells which were functional and 1 small STP inside our plant. And of course, I kind of missed out on one part, that we already had 3 bore wells inside the factory.
Okay.
So once this project started, all those bore wells became kind of defunct because we never. And as a fallout of this, positive fallout of this project is that we are definitely getting much more water than what we can consume. So the total, basically the water table of the complete area is increasing.
Yes. So after looking at the map, it's very clear that it is not a water deficient area by any, I mean, as compared to the rest of Bangalore, this has got enough water, groundwater sources, but your contributions have helped to raise the water table even more. Is that correct?
Yeah, actually, there is actually campaign which is being run by Vishwanath sir here in Bangalore.
Yes.
We are on a process of creating 1 million wells in Bangalore. So these are either open wells or recharge wells. Now, actually, what happened over a period of time, we have gone too much into bore wells. Now, bore well is tapping a aquifer which is quite deep in Bangalore. Like nowadays, you don't get water till you hit almost 1,500 feet. Okay, so we have forgotten about our open wells. These are, on the above surface, the aquifers which are on the top of the surface, earth surface, and in RWF, like we are getting water at almost within 10 to 20 feet. So we are not exploiting actually water which is coming out of borewell. That is what is essentially called, ancient water. Those are not aquifers which can be very easily recharged, whereas open wells, they can be recharged by rain cycle. So yeah.
No, so what you've done is you have a water body which actually charges the well.
Exactly.
And the pump intake is inside the well.
Yeah.
And you're using the soil as a filter so that the pump water is relatively pure as compared to the.
Yeah. In fact, somebody has put a question in chat box about the water quality. So all these 4 wells we are regularly checking, and even though we are in a industrial kind of area, the water quality we are getting it tested as per the IS potable water requirements, and all the parameters are within the range. I was a bit apprehensive about the ferrous content and all, but that is also within range.
Okay.
And part of it is, I feel, because of we have left the vegetation as it is. So this cat's tail, especially this kind of plants and all, they are very good filter for lots of metals and other things.
Yeah. Actually, your talk has inspired me, the previous talk that I heard, to implement something in my society. Now it's a,
Oh, I'm
yeah, it's a very,
Apurva.
yeah.
Apurva, sorry to interrupt you. I see a comment from Vishwanath sir. I believe
Vishwanath
he
sir
has
is here.
joined.
Okay, great. Yeah.
So,
Can
Farooq bhai, I'll request you to put him, if you can just,
I will do
Let's
that.
hear. Yeah.
Apurva,
Yeah.
I'll request Vishwanath ji to put on his
Yeah.
this. Till then, you just get DBH into the conversation.
Yeah.
By the time I get Vishwanath
Sure,
to
sure.
open his this.
DVH, your questions, please.
Yeah, actually, Ajay, this is Devdatta Hambardikar, and I also worked with Farooq almost for more than 30 years. Okay. I just saw that the costing that you have worked out is really, really low. I mean, making such a huge water body, the typically the municipal corporation would have spent almost lakhs of crores, and what principles you have used are actually a frugal engineering. And how did you get the inspiration for doing these things, to use frugal engineering rather than going for or demanding such a big budget from railway ministry also? Because it was necessity anyway for the railways also.
see, one part of the cost which is not actually taken into account is the manpower and the equipment cost. I was lucky to have, these heavy equipments inside the factory. And I told my team, okay, like 7 days in a week, you are using the equipment in the factory. One day you give for that area. So one day we used to plan our, activities in such a manner that these 2 dumpers and the poke lane and everything will go in that area, low-lying area, and they will do a mechanized Shramdan kind of thing.
Mhm.
So of course, cost of hiring those equipment is probably most expensive part. That was one thing. And second thing, I deliberately did not made any concrete structures or reservoirs in this project. So that resulted in lots of cost saving.
So
And how to go about it? Basically, what was happening was during this time, always I used to walk in that area and see how water is behaving. And try to understand the flow of water and take minimum intervention so that the water can go to relevant portions.
By the natural flow of
Yeah,
that was the main thing.
taking advantage of the gradients present there.
Gradients, yeah.
so
I could see that in one of your pictures you have used that multiple layers of water for filtering also and taking out the dust. Yeah, that's good thing.
So Ajay Singh,
Yeah,
I
Farooq.
just want to tell you that Devdatta Ambadikar has designed one product which converts hard water into soft water. It's a product which sits on the pipe, and with radio waves, they align the ions of the water so that the damage on the pipes and taps don't happen. Yes,
And just to prevent the scaling and also oxidation inside the metal pipes, basically.
So Apurva, Mr. Lokhandwala wants to go. So can we give him a chance to speak? Lokhandwala, kidhar gaya wo? He comes and he goes. Anyway, so can you request Vishwanath ji? Vishwanath ji, can you please come on the line and speak to our audience? Vishwanath ji,
What can I talk about? Ajay Singh ji has covered it so beautifully with such great photographs and such great fashion. उसके आगे कुछ बात करने की जरूरत नहीं है. बस जैसे उन्होंने invitation दिया, the invitation that is given, if you are lucky enough to come to Bangalore and see the place, then the real thing, the chamatkar that has been done will become visible. So nothing more to add. The whole thing has been spoken beautifully and eloquently.
What's your background, sir? Vishwanath ji, what are you? I can see you've written a bio, some trust, you belong to some trust or something, bio, something trust.
Correct. So I'm a civil engineer. I'm an urban planner by qualification. I'm one of the chelas of Shripad Reji, who's here. So, and I work on water, and I've been working in the water sector for 35 years.
Yeah. Very good. Excellent.
Farooq bhai, that is a very polite way of giving his introduction. But as far as I'm concerned, a word of encouragement coming from him in this public forum is almost like a Nobel Prize for me.
What he has written,
he's a guru, my water guru.
He has written one of the critical acts to harvest water is to walk out during the rain, Sri Ajay Singh did many walkabouts at night during Sundays, any time of the day to understand land and water. There is no substitute to walking and understanding the landscape deeply and viscerally. Both the wetlands and the soil are the natural filters for the well. Superb job done with great dedication. This is the message Mr. Vishwanath ji has typed in the chat box.
Thanks a lot.
This one, there are two people who raised their hand. One is Mr. Soumya Chatterjee and one Mr. Sanguni. So one of you can, I've given you permission to talk. Please can.
Professor Sanguni, yeah, I love to hear him. He's again a great inspiration. He's heading our Putinali Lake Trust, which he's trying to save the lake and the bird sanctuary.
Very good. Yeah, Sanguni sir, aap boliye.
Yeah, okay. Thank you, Ajay Singh. It's beautiful. First part of it, I was watching through my friend's cell phone. I switched over, came home. Nice. Then I just wonder whether 2015 you were there in Rail Factory. That time, yes, the water, and now the water quality, how is it? Any changes there in open well? Because earlier, if I remember, all the sewage is flowing through that wetland to the Yelahanka lake. When we are starting desilting to the Yelahanka Putinali lake, I found a lot of sewage is there, virtually sewage pool. So the open well will have some sewage inputs also there. And Yelahanka, especially the bore well, is polluted by chromium. That is a big story. So with all these things, you are able to bring out a water quality so that you can use in the factory, and also use personally. That's a great achievement. Which really, this is a showcase for everyone to follow the rainwater harvesting and as open well. Unfortunately, open well are closed in all our new town because of sewage. So I'd like to know, is there any difference between then and now about the sewage? Or pollution?
Sir, what I recollect from the results, what I had taken, the results actually, I kind of thought about taking regular well results was somewhere around 2018. So I can't really say 2015 what was the condition in the well. And but I do remember that all parameters were within control. So it was a big surprise for me also, personally speaking. So I'll be happy to share those results. Some of them are still with me in my laptop. We can sit and have a chat on those.
Okay. So can we request Mr. Soumya to speak something? Sanguni sir, आपको कुछ बोलना है और कुछ?
Yeah, nothing, sir. Let Soumya talk.
Yeah, Soumya, please speak. And I'm going to invite Dr. Barucha also to speak. He is one of the greatest environmentalists from Pune. And Mr. Soumya, please speak.
Sir, good evening. This is wonderful, and I wish to convey my many congratulations to Ajay Singh sir for such a wonderful thought process and working to that area, because water is precious to each and every one of us. Water is very precious, and we must think about that in a very proper manner, because everywhere railway requires a lot of that kind of water. Even for washing the railway coaches, we require a lot of water. So if that can also be translated into that kind of recycling kind of thing, that will be wonderful. And constructed wetlands can do wonder. They are the kidneys of nature. So, Ajay Singh sir is just trying to rejuvenate all these constructed wetlands or wetlands rather in his own fashion. So I really appreciate from core of my heart and wish all the best. If there is any requirement from any of us, we'll always be there along with sir.
Soumya sir, from Bangalore, say you are from Bangalore?
Sir, no, I am basically working in DRDO. I am from Tejpur.
Tejpur, okay.
I am working with the bio-toilets, basically DRDO biodigesters bio-toilet. Yes.
But it's amazing the work. DRDO also has worked with Ajay Singh for creating those bio-toilet design, I think. So that's what he spoke in the.
Thank you, sir. Thank you, sir. It is basically a joint collaboration kind of thing. So I must congratulate sir also for all these things. And
But it is railways who has made, yes.
Farooq bhai, one request. I see Shri Padre Saab. He has joined from Kasargod. He is also one of my water gurus.
Yeah.
If you can put him online.
What's his name?
Shri Padre.
Okay, I have given him permission to speak. Mr. Padre, please, you can speak up, sir.
Hello.
Yeah, please speak up, sir.
Thank you for the opportunity. I was very happy to be a listener, sir. Because there's such a the people who don't know much about who haven't entered the world of water would think that what Ajay Singh ji was telling is a Chandamama tale, but really it is not. And what a befitting description finally Vishwa gave, because just walk in the rain and keep your common sense, walls of your common sense open, things start happening. Wonderful, sir.
Yes.
I don't have much to add, but one thing that always Vishwa, the open wells have a history of 4,500 years, and these wells have come only 60 years ago. So if we can't revive and if we can't keep up our open wells, with water, probably nobody can do in elsewhere in India, especially in our area and all that. So let us have more confidence on open wells, the shallow aquifers, and what Ajay ji has mentioned about the great project of having million recharge wells. Recharge well is such a beautiful concept which we in Kerala, Karnataka hasn't given much thought to. Thank you, sir, with these words. Thank you for the opportunity.
Thank you for your words, sir.
Sadhi sir, would you like to speak?
Sir,
please unmute yourself.
I have given him permission to unmute.
Yeah, but he's not unmuted.
He's unmuted. Okay. Sandhi, I've asked you to unmute. Sandhi, he's from Portland. He has just woken up just now. He has written one thing in the chat box. I'll read it and you can answer. Sandeep Prakash is from Pune and then he went to work in Intel in Portland. He has written also, I would like to introduce you to, Sandeep Vaslekar, President of Strategic Foresight. He's world famous, known for water and conservation. He's also written about things like in Pune we have the Mulla Mutta River, which join hands and join the Bhima and then the Krishna. He's asking you, Ajay Singh, is that Pune, where Mulla and Mutta rivers are drying up, can the down areas from rivers be turned into water bodies along the way? Then he continues, can existing satellite geospatial and remote sensing data be used to identifying right areas for creating lakes? Can technology be used to help us? What is
Farooq, I just came online, so thank you for repeating my question.
I'm reading your question. Tell me. Sandeep, have I put the question properly?
Yes. I think, first of all, I must congratulate you for the vast amount of work you are doing. I think water, people don't understand water is the new oil for the world. We are going to run out of water and drinking is going to be a major problem. I think you are using water in very innovative ways to solve the problems. I first want to congratulate you before asking questions, but those are the questions. The first one, as he repeated, Mulla Mutta River is an eyesore because all the water is caught in Khadakwasla and Panchit Dam. There is really nothing, and all it creates is down the stream is just filth. Can we create water bodies along the way using the basin of the rivers to turn into water bodies?
Sir, what question you have asked, I feel a bit unqualified to answer that. I'd like to focus on my, area of influence. But yes, what I firmly believe is that if you look at from the perspective of water, you try to understand water, then I think even a river problem can be solved. I'm having that confidence. And yes, that will need lots of concerted effort because, of course, the technology will definitely help. But as Vishnath sir says, nothing can beat, just walking around the river banks and, trying to figure out what's going on there. So definitely these problems are not kind of non-soluble problem. Basically, it's a matter of, somebody at the right position trying to take almost bullheaded approach and kind of doing things which are required to be done. Very, very basic and fundamental things.
So, Ajay Singh, I'll just add to what Sandeep Prakash Bede said, and since we are from Pune, because of this rapid urbanization and this, buildings getting constructed, about 2 years back, we had some, 2 or 3 years back, I think we had some absolutely stupid floods in Pune. Kabhi zindagi mein udhar flood nahi hua hai. You remember that flood which took place, then we discovered that there was a natural nala there. Huh? You remember?
Padmavati side also.
Darwala, Dandekar Pul ke paas bada flooding ho gaya tha, and the low-lying areas were flooded and people lost their lives and all. So these type of nalas, I think so. I don't know if we create some sort of awareness, then we can push the corporation to do some things.
Even
Farooq sir,
most of the
Farooq sir, you are an engineer. I am an engineer. Just one point I'd like to make, and Vishnu sir is also an engineer. We have few engineers here, but what I feel that sometimes a plethora of engineering projects, they somehow miss the basic fundamentals, and we try to throw our engineering firepower and forget about the fundamentals. I think we have to, for solving water problems, we have to see from the perspective of water. Water is something which you can't, maybe you can fool it for some time, but if you do construction which is coming in path of water, sooner or later, it will hit you back. And we in railways are, kind of learning it the hard way, because many places we have constructed things and suddenly one day a landslide will be there. If you get into root of it, it is all because of water. Water is not getting paths, so it will create a path. It is as simple as that.
So I would like to now invite Dr. Eraj Bharucha. I have given you permission to speak. Bharucha say, Professor Bharucha, Dr. Bharucha is a #1 person for environment.
Please.
This is the book that I bought yesterday.
Yeah.
Huge volume. Huh?
Just a little.
Eraj, speak, please.
Yeah, here I am.
Yeah.
Good evening to all of you, and thank you for asking me to speak.
Good evening.
This has been an incredible presentation. But more than an incredible presentation, you're an incredible human being.
Thank you, sir.
Because you have been able to combine your engineering knowledge with this sensitivity to natural resources, which to me water is the biggest one. And what you have therefore been able to bridge the gap of putting these two things together is what makes this presentation so fantastic. And I was really surprised that it's only 5 years old. And that's commitment, and that's what comes out of people wanting to really get something to happen, and that's vision. So I'm really very impressed with this show. It's been very pleasant listening to you.
Thank you, sir.
I wanted to know one thing from you. When you first said you wanted to create these water bodies in this place where you were actually supposed to make railway wheels and axles, what did people think about this? How come they never asked you, अरे भाई तेरे को तो रेलवे के लिए wheels बनाना है, wetland क्यों बना रहा है? Did they ever question you about this? Because I remember Sumant Mulgaonkar, who started Telco and made the most incredible in the 1950s, 60s. He already was doing incredible water management, very similar to what you have done, and sometimes very innovative as well. He built a whole lake. And in building that lake, he was asked as the MD, what the hell, are you supposed to make trucks? Why are you making this lake? And he said, someday we are going to need this water.
I saw.
All that water. And Sumant did incredible work on this. My personal experience is with Pashan Lake, Pune, which through JNN URM funds, we actually rejuvenated because it was down to 1/3 of its capacity. And people ask me, how are you going to do this? The municipal corporation was that time quite sensitive to doing this. And I said, you'll have to dredge and empty it and dredge it. And they said, oh God, what happens if next year there's going to be no rain? So things like that happen. And when we dredged the lake, we found that though it's a 150-year-old dam, the top 8 parts of that top part was all building debris which came from upstream. And only that little part of the thing about the Murram soil was probably 100 years old. So we had to go there every weekend and tell the bulldozer, "Abhi yahan band karna bhai, or don't do anything more here," because we were worried that we will get a huge seepage afterwards. What also happened was about a year, it took about 2.5 years. A year after this, the commissioner phoned me and said, "Doc, what am I supposed to do with these huge tons and tons of debris that's coming out there?" And I said, "You're the commissioner, you pitch it somewhere." And he said, "Well, give me some ideas." So I said, "Well, there is this new sort of bypass coming there. So you build that up so that we can afforest it, use endangered species. But very important, within that lake, it's quite a large lake compared to what you have, I said, you build a small island, because that is what will bring your biodiversity back."
Correct.
Sure enough, we have got nesting storks,
Birds and
nesting spoonbills, we've got nesting ibis, and a hell of a lot of migrant fowl which had not come there for at least 15 years are coming back.
Oh, I had no idea this is a man-made island.
Yes,
Wow.
yes, of course.
But removing the debris and putting it in the middle.
Fantastic.
But the important thing in this, Ajay, is that the wetland that you rejuvenate, yours are fresh wetlands, but when you rejuvenate a wetland, invariably they reverse if you don't look at what's coming in. And that's the most important thing about this. Today, after we have done this 10 years ago, we are gradually reversing this trend, and I'm talking to the corporation to say, if you leave it like this, you'll go back to where you were.
There you go.
Thank you very much. Farooq, as usual, thank you for asking me to speak. It's been very rewarding evening. Thank you very much.
So next week we are going to have Dr. Araj Borucha speaking on Salim Ali, by the way. Achha, so, Mr. Apurva, I think we have spoken enough now. I request you to give a vote of thanks to Ajay Singh, sir.
Yeah, Ajay, this was absolutely a mesmerizing evening. We learned so much. I know so much about your work, but it was like as if I didn't know you at all. And I learned so much new things, and I'm inspired to do many things. And I'm sure many of the people who are seeing this evening would be inspired to do something. And in the heart of it, it is very simple. It's common sense. It's something which you know. So my thanks for taking time off from your busy schedule and showing us your presentation and talking to us. And we look forward to seeing you again in some future program of this thing. And also join with Farooq Bhai on the Urdu channel. I can see that that's your interest.
He
Okay.
joins. He
He
joins.
joined. All right. Right. So thank you so much. Yeah. Bye.
So
Thank you. Thank you, Apurva. Thank you,
Thank you very
Farooq
much,
Bhai.
Ajay. Yes, please speak.
And thanks to the Gyanadab platform.
Yeah. And it was good to have you, sir. And it will be our pleasure that you join our Gyanpedia group, because we are doing some wonderful programs on nature. We did a program on tigers. We did a program on birds. And, it is really, and we have a very small group, and mostly all technical and all, want something unique, So,
Okay.
and one of the days, Ajay Singh, please talk to us about the bio-toilets, the amazing work that railways have done for that. I'm sure you'll be able to give us a presentation on that. We'll talk shit one evening.
That would be an interesting subject, actually.
As I told you, Hambantikar, when this guy, Bihar Chief Minister Lalu Prasad Yadav was a rail minister, he went to Germany to meet the railway ministers and all with his whole team from India. And the first question he asks is, the Germans is, how do you handle your shit? And that was the start of the way the bio-toilets happened.
In fact, that was a time when I was in the ministry.
Yeah, you were in the...
Yeah.
And to the trip to Germany?
No.
Okay, Okay, sir. With kind permission of everybody, can I call it quits now?
Thank you, Ajay. Great.
Chalo.
Thank
Good
you.
night.
Thanks,
Good night,
everybody.
everyone. Bye.
Thank you. Bye.
See you.
Excellent, by the way, Ajay. Just for your presentation, I woke up really early to hear your presentation, and I was.
Friend, it is 6 o'clock in the morning now.
Oh, thank you so much.
No problem.
Thank you, everybody.
Good night. Bye, everyone.
Bye.
Bye.